Welcome to The Explainer. Today, we're pulling back the curtain on computer networks. We're going to demystify the invisible rules that control pretty much everything we do online. Every email, every video, every single search. And it all starts with a really simple question.
Have you ever really stopped to think about it? How does your phone, right there in your hand, have a perfect, seamless conversation with a server that could be thousands of miles away? That's the core puzzle we're going to unpack, and we'll think of it as a digital conversation.
Every conversation has a kind of vibe, right? Sometimes it's a free-for-all where everyone just chimes in, and other times someone's clearly in charge. Well, it's the exact same for networks. The very first decision you have to make is about the structure. Is it going to be a party, or is it a hierarchy?
And that leads us to the two fundamental ways to build a network. The source material puts this perfectly. Are you setting up a party of equals, or are you building a hierarchy with a boss? That one simple question pretty much defines everything that comes next.
So these two styles, they are worlds apart. Peer-to-peer, that's our party of equals. It's awesome for small, informal stuff. Think of a few computers in an office sharing files directly with each other. It's decentralized, it's easy, but it doesn't really grow well. Now, when you need to handle huge amounts of traffic, when you need to scale, you absolutely need the hierarchy with a boss. The client-server model is what makes the modern internet tick. You have a powerful central server that manages everything, giving you the structure and power to run the services we all use every day.
Okay, so we've picked our conversation style. Check. But what about the etiquette? The actual rules of engagement for how data flows back and forth. Let's think about this one as a choice between using a walkie-talkie or just having a normal phone call.
And the difference, really, it all boils down to this one thing. Do you have to wait for your turn to speak, or can you both just talk at the same time? That simple rule changes the entire flow and the efficiency of our digital conversation.
First, you've got Half-Duplex. And honestly, this is basically a digital walkie-talkie. Yeah, you can both communicate, but it's only one direction at a time. I talk, then I have to say over, then you can talk. You have to wait. It gets the job done, sure, but it feels pretty slow and clunky. It's not a real conversation.
But then there's Full-Duplex. Now this is the upgrade. This is like a modern phone call. Both people can talk and listen at the exact same time. The data flows in both directions simultaneously. This is obviously way more efficient, and it's the standard for pretty much every connection we use today, from the internet coming into your house to the ports on your router.
All right, so we've got our conversation style, and we've got the rules for talking. Now let's meet the actual participants in this whole thing. The hosts, who are the ones actually having the conversation, and the guides, whose job it is to make sure the messages get where they're going.
So who's who here? Well, every conversation starts and ends with what we call a host, or an end system. That's your device, your laptop, your phone, a web server. These are the devices that are actually creating or consuming the data. But to get the message from one host to another, it needs help. It relies on intermediate nodes, the guides. Think routers and switches. Their only job is to be like a postal service. They read the address on the message and just pass it along the best route. They never, ever change what's inside.
Okay, let's pull the camera back a bit. We've got our hosts and our guides, but how are they all arranged? This seating arrangement is what we call a network's topology, and it has a massive impact on how reliable that network is. Trust me, some arrangements are way more robust than others.
Now, if what you want is the ultimate bomb-proof, never-gonna-fail network, then you want what's called a full mesh topology. In a full mesh, every single device has a direct, dedicated connection to every other single device. What that means in practice is you have tons of different paths for your data to take. So if one of those connections gets cut, no problem. The traffic just instantly finds another way to get there. This makes the network incredibly fault-tolerant and reliable, but as you can probably guess, it's also the most complex and expensive way to build one.
All right, we've covered the models, the rules, and the physical layouts. But now we're getting to the big reveal. This is the part that might challenge what you think you know. We're going to look at the difference between what you can physically see and what you actually get.
So let's think through a little puzzle from our source material. Imagine a network where all the cables are physically wired up to a central box. It looks like a star. But when you actually use it, every single device can talk to every other device as if they had a direct private line. So how is that possible? If it's wired like a star, why does it behave like a super connected mesh? What is going on here?
The entire answer to that puzzle lies in this one critical distinction. On one hand, you have the physical topology. That's what you see. It's the literal physical way the cables are laid out and plugged in. In our puzzle, that's a star. But then you have the logical topology, and that's what you get. This isn't about the wires at all. It's about the path the data is allowed to take. It's about the rules of the road.
So the solution to our puzzle is logical topology. It doesn't actually matter that the network is physically wired up like a star. That smart switch in the middle is creating virtual paths, allowing any device to talk directly to any other as if they were all connected. And this reveals the core idea here. The physical layout shows how a network is built, but the logical layout shows how it behaves. The path the data follows is what truly defines the conversation.
So when you put it all together, the style of the conversation, the rules of etiquette, the critical difference between what's physical and what's logical, you start to see that our entire connected world runs on these invisible rules and designs. It really makes you wonder, doesn't it? As technology gets faster, smaller, and woven even deeper into our lives, what will the next digital conversation even look like?